With a quick rearrangement of the margin of error equation for estimating proportions, we can ask an opposite question. Now, instead of finding the margin of error, we can ask how many people do we need to sample, or how large does our sample size need to be in order to have a certain margin of error. So you just rearrange the margin of error equation and you end up with that n, the number or the size of your sample size. N has to be your sample proportion times 1 minus your sample proportion times a z-value squared divided by the square of your margin of error. Now, if you know your sample proportion, then you can figure out your 1 minus sample proportion. But if you don't know your sample proportion, the best estimate for PS times 1 minus PS is 0.25. That's the maximum of PS times 1 minus PS over the interval 0 to 1. So at worst, you can replace that PS times 1 minus PS with a 0.25. And we'll copy the rest of the equation down. So use this one if you know your sample proportion. Use this one if you don't know your sample proportion. So let's answer a question. We wish to estimate the true proportion of green marbles in a jar. How many samples do we need, or how many marbles do we have to measure to estimate the proportion within 1% with 99% confidence? So we want to be 99% sure that we are within 1% of the actual true proportion of green marbles. So because we don't know our sample proportion, we haven't tested any marbles yet, we're going to use this second equation where I replace the PS times 1 minus PS with 0.25. Okay, now let's figure out the z-value and the margin of error. The margin of error is given to us in the problem. Right? This margin of error, I'm supposed to estimate my proportion within 1%. So that's 0.01. Now let's figure out what this z-value is. So our z-value, that's going to come from how certain we want to be. We want to be 99% sure. So if you draw that picture and you have 99% in the middle, then that means you have 0.5% here and 0.5% there. So this z-value right there that matches our picture has 0.5 plus 99, so 99.5% of the area to the left of it. Let's navigate to our z table. I'm looking for the z-value that has 99.5% or 0.995. That's how much area to the left of the z-value that I want. So I look through these values until I find the probability of 0.995. And I think I'm trapped between two values. Here is 0.9949. And here's 0.9951. So 0.995 is right in the middle of those two. So let's take the average of these two z-values that we get. For the first box, the z-value that has 99.49% of the area to the left of it is going to be 2.5. What's the third decimal place or second decimal place? 2.57. The next one will be 2.58. So the one right in the middle there is 2.575. Right? These tables are just estimates anyway. So the z-value of 2.575 is probably very, very close to the z-value that has exactly 99.5% of the area to the left of it. So the z-value that we're looking for is 2.575. I don't like that. Let's go through this equation slowly. 2.575. So my numerator becomes 1.65766. My denominator becomes 0.0001, which gives me an N value, right? This is N. The number of marbles that I have to sample is 16,576.6. Now, you can't measure 0.6 of a marble, so always round up, because 16,576 wouldn't cut it. You would need 16,577 marbles. Okay, but what if we have some information about the jar of marbles? Let's say that we reach a hand in and find that 7 out of the 19 marbles that we grab are green. So now we know our sample proportion. We have 7 out of 19 that are green. So we don't have to replace PS times 1 minus PS with 0.25. We actually know what our sample proportion is. Everything else is going to be the same. The sample proportion is 7 out of 19, which means 1 minus PS is 12 out of 19. The Z value, it's the same Z value because we still want to be 99% sure. So it's the same critical Z value that gives me a 99% confidence interval. That's 2.575. And we're still desiring the same level of confidence. We want to be within 1%. Okay, so going through this equation slowly, we get in our numerator 1.5429. Which gives us 15,428.6. But again, you can't measure 0.6 of a marble, so round that up. You need to measure 15,429 marbles. So notice it's not as bad as the first estimate when you knew nothing about the jar. When you know something about the jar, you don't have to estimate that many marbles, but still you have to measure a lot of marbles to be within 1% of the true proportion of green marbles in the jar.